Good morning, Ni Hao, to Beijing, China, from Germany. My name is Michael Sterner. I'm professor for energy storage, power to X and hydrogen. I'm one of the inventors of power to gas and power to X. I'm author of the Handbook of Energy Storage in Nature Springer Editors. And I'm glad to join you today via this video call, because I can't be there in person. In Germany, we are a team of 30 researchers working on hydrogen and power-to-X climate solutions. And we are doing this since a very long time already. We have various pilot plants set up on electrolysis, biological methanation, and basically I'm an electrical engineer, but I also study chemical engineers, so I unite both disciplines in my work. And today I will talk about the development of the power-to-X concept and the demand, the infrastructure and the generation of hydrogen and power-to-X, the regulation and new ideas which we have. And I conclude with my thesis that we need China for hydrogen and power-to-X market ramp up as we did for solar and batteries. So, how did we develop this power-to-X concept? It has a lot to do with the German energy transition. We have installed over the last 20 years a lot of renewables in Germany, especially wind and solar. But this is not to be compared with China, because you have installed in May already so much PV as we have installed in total 20 years. So there's a big revolution going on. Wind and solar are the cheapest sources for electricity worldwide, and we have to tangle the problems with this. So wind and solar won't make the energy transition on its own. We need to meet the consumers. We have to deal with fluctuating resources. That's why we need networks and storage systems. And these storage systems have to be short-term, like batteries. So there we have the battery boom in Germany, also like the solar boom, and driven by Chinese products, which are affordable and reliable. And so then we have a complete picture. When we started, people told us 20 years ago, it is not possible to have a 100% renewable electricity-based system. So we did modelings and we identified that we have in a 100% renewable electricity system only the gas storage with sufficient capacities. Batteries, electric vehicles are good, but they won't last for 2 weeks or even more. And we have big gas storage facilities in Germany that could take up the surpluses from wind and solar. So we designed a system being consistent of gas and electricity, and we asked ourselves, can we combine both? And we did this by imitating photosynthesis, because nature stores energy for long periods of time by using solar irradiation, splitting water into hydrogen and oxygen. The oxygen is released, that's what we breathe in. Also our machines and combustion engines use this. But nature does not stop at hydrogen. It uses CO2 to store hydrogen. And that's what we use as fossil energy, as biomass, what we eat every day. So that's the natural way of energy storage. And we as engineers asked ourselves, can we copy this? And we did this in 2 stages, by splitting of water electrolysis, and then hydrogen reacts with CO2. We copied this by, of course, doing electrolysis. So this was not really new. But what was new was to use CO2 methanation in energy systems for energy storage. Everyone knows Sabatier process, but this hasn't been applied to energy storage. So we were the first ones that were able to patent this. And then we have a complete existing infrastructure which we can use for this hydrogen carrier. It has the same properties like natural gas. And that's where we ask ourselves, how can we call it? And we propose to call it wind to gas. Later we said it's electric gas. e-gas, e-fuel, or later we said, let's call it power to gas, because then we have the gas storage accessed and we can supply the electricity system with stored green energy at any time. And then already we said, okay, we can also go for mobility or for heating system or for industry. But the initial idea was really to couple electricity and gas networks. Out of this, the sector coupling arose. And this was back in 2008 with some colleagues. So we did also the proof by really having one container to extract CO2 from the atmosphere. The other one did electrolysis and combined it in a methanation reactor, a chemical one. And then we had a fuel maker to fuel gas cars. We did this in Stuttgart. That's where we also met Fang Mai and other colleagues from China who were really fascinated by the idea. And then later on, we got with Audi a 6 megawatt chemical methanation plant from MAN, which was built and still is up and running. So we did the proof of this. Later on, I wrote my thesis on this, on sector coupling. So we have the electricity network. Everything is connected to this. We integrate power to gas using CO2 from the atmosphere or from biomass. Then we can really run a 100% electricity system. We can also go to the heating system because we can use heat pumps, but sometimes we need gas-fired heating systems and CHPs. We can fire this with electric gas. Same in transportation. We can drive electric vehicles, which is the most efficient way, but we can also generate electric fuels, e-fuels, how we called them, to drive the combustion engine CO2 neutral. So this was the idea of sector coupling in my thesis back in 2009. I was 31 years, so now I'm 47, and I'm happy that this concept really emerged. We also introduced CO2 recycling and CCU. You could also use CCS. You could also go for a pure hydrogen system, but I think CO2 will remain in the energy system. As long as it's CO2 neutral, it's fine. So everything starts from solar radiation, the water cycle, photosynthesis, wind power, and solar energy. We have dealt a lot with the generation side, but we haven't really thought of the consumption side. And in between, we need electricity networks, gas networks, fuel networks, heat networks, and the linkage in between, which I call power to X. And after some times, people came up, let's not only do power to gas, we can also do power to liquids, power to chemicals, power to products, power to food, whatever, everything based on renewable electricity, generating something. And I proposed to call it just power to X. And this was back in 2014, and everyone picked it up, where I'm glad. Then we did also the modelings for this. We modeled global scenarios to shift towards wind and solar and biomass and geothermal energy, plus power to X, which you need for electricity stabilization, for heating, for transportation, of course, also for the chemical industry. And all this history of developing power to gas and power to X, we finally published in a peer-reviewed paper in Energies back in 2021. You can read it there. So now, what's the demand in Germany? First of all, we did an energy model with almost 400 pathways out of this 170 power to X pathways, where we use all electricity sources and then really deeply dive into the power to X pathways on the residential systems, on the industrial system, on metal production, on ferrous metals, the basic chemistry from ammonia to chlorine to methanol, whatever, polymers, high-value chemicals, nutrition, mining, glass, pulp and paper, everything, and also the complete transport sector. So for Germany, we found out we will double the demand of electricity through electrification with heat pumps and electric cars and hydrogen. So this is really a booming market, the electricity market. The heating market will go down because of better technologies like heat pumps and better insulations. There we hardly see hydrogen. We see some hydrogen in the mobility case, as long as we do not have electric lorries. So there's a competition in there, but surely we need some e-fuels for planes and ships. Otherwise, we cannot get CO2 neutral here. But where we definitely need molecules and hydrogen and Power-to-X is the industry. We see, of course, biomass for paper and cement industry, electricity for steel, glass, and so on, power-to-gas for process heat, which we cannot supply with electricity, and Power-to-X, of course, for the chemical industry and steel manufacturing. So overall, we see a high demand growing for climate neutrality. So we have 3 million tons of ammonia, 1 million ton of methanol. We have a lot of kerosene demand. We need high-value chemicals based on hydrogen and Power-to-X, steel, transport, electrification, so on. So up to 700 terawatt hours, which is a huge market. But how do we get there? Well, of course, we need some generation. And we tracked from the very early stage when we first started our own Power-to-X pilot plants, we tracked them and we saw, there's a development out of Germany and on China and so on. And we published this in Renewable and Sustainable Energy Reviews back in 2019. And it's with 500 citations, one of our most cited papers so far. It went to the IPCC reports and so on. So implementing Paris global climate protection, that means Power-to-X and hydrogen becomes a global market. In Germany, we had also the hydrogen strategy. I'm a member of the National Hydrogen Council and counseling the government for many years now. And we had the release in 2020 with a lot of billion euros for a framework for action. We updated it 2 years ago. We added the import strategy last year. And there are billions in the budget for creation of demand for imports via H2 Global. And we have also the Hydrogen Core Network now funded mostly by public money. So yes, we have potentials. We show them at the hydrogen map in Germany. We have also released this atlas where you can go into every district of Germany and see where are plants, where are potentials, how high are the costs, where are jobs, who is working there, who is researching there. We've put everything into this map. But we see, of course, if we look at these results, when we started with our first pilot plants in 2008, 2009, nothing came along the last 10 years. So we hope now really for a boom, but so far electrolysis is quite expensive and we don't see this boom. So the German government goals won't be met from today's perspective because electrolysis is still too expensive. That's why we look also very much on the imports because the European Union plans to import at least half of hydrogen and Power-to-X demand by 2030. And of course, the most efficient way is to use direct hydrogen via pipelines. But we looked at IEL and PEM technologies. If you go to synthetic methane, like we proposed with Power-to-Gas, you have as well a technology that is ready for market and the efficiency and development time and construction times are quite okay. If you use DAC, of course, this is a harder thing. I mean, DAC is essential and many research is going on around the globe, especially in China. I've seen many papers. So that's really a core technology, direct air capture, to solve this. But so far we see the technology readiness level quite low and the development times are quite high. So ammonia has there a benefit because it doesn't use CO2. Methanol, if you use point sources, is also viable, especially also for SNG or LNG. And we've published this in the International Journal of Hydrogen as well to compare efficiencies and technology readiness level over the complete import chain. So the infrastructure which we have in Germany or in Europe is large. We plan to really refurbish or reuse old pipelines for the hydrogen backbone and have a lot of repurposed gas pipes. But if you look at the storage side, and that's the cover of our book, you can clearly see that batteries and pumped hydro storage are too small, but aquifers and caverns really are nice, and we have plenty of them in Europe. But if you have just a look at Germany and you convert this gas storage with methane, SNG, to hydrogen storage, then you have only a quarter of the stored energy at 200 bars pressure of underground storage. So clearly this would not be the way, and we would need additional hydrogen storage. And I really propose to go for power to gas and methanation, because it's just 10% more costs and a bit less efficient. But you have a complete infrastructure which you can use. You do not have to build up new hydrogen storage, hydrogen pipelines, hydrogen applications, and so on. So in my point of view, it's much more easier. We have also some issues on the regulation side, because we have not only friends from hydrogen in Europe, and the regulation said if you use renewable electricity, it has to be new electrons, not the old electrons from old wind and solar. And it has to match temporally and geographically, and you have some limitations on the carbon source. So overall, this is like if a baby wakes up and you say, okay, start to read, start to write, start to calculate. It's much too early to impose such strict regulations, especially as this adds €2 per kilogram of hydrogen, so it makes it unnecessarily very expensive. And that's without need. It's just to avoid that electricity goes into hydrogen. It should be used as in electric cars and heat pumps. That's why they have put these laws. But finally, we don't see a hydrogen ramp up because of these regulations. I'd like to point out, especially from the carbon sources for power to X, that's really not logic. We have 100 terawatt hours of biogas. We could double the potential via power to gas and hydrogen, and really fill up our own gas storage via our own natural gas or synthetic natural gas. But we are not allowed to use CO2. Now, have a look at methanol, or if you have any source like cement factory. You have 2 CO2s if you just do the conventional fossil way. If you use this carbon from the point source and produce methanol or methane, then for the climate, the effect is the same. It's just 1 CO2 more. But the legislation says it's only CO2 neutral if you use DAC. So you can place a DAC facility beside a point source and then you are carbon neutral. But as you know, that's quite more expensive and a lot of technical effort. So that's really a massive hinder of market ramp up of regulation in the European Union. But we have also new ideas. So first of all, 5 years ago, we developed a new instrument called H2 Global to overcome the chicken and egg problem, with a competition-based instruments where you have a long-term contract on the supply side and a short-term contract on the off-take side. And this double-side auction scheme really reduces the costs. And anyone can define the criteria and give money into this. It's really a national and a global instrument which you can use to really limit the funds you need and increase the maximum of climate protection. So that's the way to go. And we've already saw 5 years ago that ammonia will hit the place first, especially if CO2 prices rise. And the first auction which we did with this instrument we came with ammonia for €1,000 per ton in 2027 from Egypt, using new wind and solar parks, existing ammonia infrastructure. Also, the first European Hydrogen Bank auction winner was e-methane, SNG in Finland, also using existing infrastructure. So using existing infrastructure is really a cost saver. And additionally, we had the ideas not only to use hydrogen at land, but also from the sea. So we thought, why not invent ships that really go to the sea and do nothing else but harvest wind energy? Then you are absolutely free outside and you do not have to follow any national rules. You can just harvest energy out there. And the idea is to do a kite, which is driving an electric generator, and again the electrolysis. So sail energy is the term which we use there. So finally, I'd like to conclude, we need China for market ramp up of hydrogen and power to X. Why? Let me give you my takeaways. First of all, I think you saw that we can really change the world with good ideas and profound research. We invented this wind to gas, converted to power to gas to power to X, and it really changed the world. So rethink green molecules, wind and solar. I had calls also from Ferdi Schütt and others which are now in the plenum. They said, are you crazy? It's not the way which we do from fossil, oil and gas, and then we convert it to our chemicals. But you do it upside down. You use electricity, the most valuable source. No. If we have cheap wind and solar, it's really reasonable to convert everything which we need, also chemicals. So use these new ideas and drive them forward. Second, we need hydrogen and Power-to-X for climate neutrality globally. And using existing infrastructure really saves cost. You do not have to rebuild everything from the scratch. And the most important challenge is the cost reduction of green hydrogen. And the solution, in my point of view, is a cooperation between China and the European Union or Germany. Why? In Germany, we have good technology, but it's 10 times cheaper to do the electrolysis in China. So why not make use of this big advantage, like with solar panels and batteries, and drive the energy transition in Europe and Germany? I really think China can accelerate the global hydrogen and Power-to-X ramp up, and I'm happy if you all join in. And join forces, we can solve the climate problem, we can get more independent from fossil energy and create more peace around the world because we avoid large geopolitical conflicts. Everything is in our hand, the technology. Let's use it as engineers for the sake of humanity, for the sake of the world. And I'm very happy now to answer your question. And if you contact me and connect with me, I'm happy that we jointly go into the future, which is bright and beautiful. Thank you. Xia xiang and ni hao.